Hello, everybody, and welcome to another session of Pi Day 2022, one of many. So I hope that you will find that interesting for your business, for your leisure, wherever you are. Good morning, good afternoon, and good evening, and good night. So what will be the theme today? The theme today will be an argument, a topic, which is called the Suitcase project. So there has been many speculations about it, and there is the code name of this project has been made by a customer. So we will see in some details what are the principles of building a suitcase, which is battery powered, with some capabilities. And these capabilities includes, of course, the Raspberry Pi. And the scope of the project will be to have something portable in order to trigger some events from the field and let the cloud do some stream analytics, stream analysis in order to detect anomalies, error, or even get some messages back from the analysis in the cloud in order to do something about specified customers. So there will be so much to discuss today. If you have any questions, please use the Q&A button. Anytime, I will try to monitor it and try to respond in real time. So this is me playing the drums. I'm nearly 60, so I'm not old, I'm vintage. I play drums, I'm a granddad, and I work in Oracle as a solution architect at EMEA level. And one of my pet projects in the past have been, the building of stuff. So the maker mode, which is, the same things that unite us, all of us. And so we will try to set quite a rich menu for this hour, and I will try to introduce to the project. I will try to describe what are the components of the suitcase, and I'll try to describe what are the cloud components, so the counterpart of what is happening on the edge, on the field. So we will see some cloud artifacts like functions, compute, and some other stuff. And we will see also some interesting stream analytics pipelines. So how to author and design some pipelines in order to detect events from the field, apply some rules, apply some patterns, apply some mathematical functions, for instance, or some, geofence, some space in order to detect and process events. And we will see some use cases that we apply successfully by customers that adopted, this kind of pattern. So let's get started. We will describe what the project is, what is the state, and what are the things available. Most of the things in this project from the suitcase point of view are over-the-counter materials, so you can buy these materials anywhere. But before this project, as a matter of fact, we will have to get a step back because we did something in 2019, so before the pandemic. And we accrued a number of experience on Raspberry Pis and microcontrollers like Arduino in order to build something like this. So we built basically a smart city made with Lego, Arduinos, Raspberry Pis, a certain number of Raspberry Pis, and cloud components in order to demonstrate not only the value of the cloud artifacts, but all the intelligence, let's say, that you can distribute between cloud components and field components. We were quite a number. We were 5 people. Each of us contributed for machine learning, for IoT, for microcontrollers programming, for Raspberry Pi programming. And basically, this project has been replicated several times, I think more than 22 times all over the world. And I think that right now, with the reopening, hopefully, knocking wood, of the offices, there will be, you know, a stable installations in the corporate headquarters. So basically, we demonstrated what we could do with some intelligent components and some cloud artifacts. The problem with this kind of installation was the size, because the size was 3 meters by 3 meters. And every time we had to assemble, you know, the CD, assemble the components that are very well hidden, let's say, soaked in Legos. And we need to do, you know, the necessary testing, all this stuff that was basically mounted time by time. But it was, you know, it was a good job. I mean, I was paid for that. So I was extremely happy until the pandemic hit the world. So smart city was no longer, let's say, a factor per se. Let's say that all the attention was projected towards the safe city because of what you know, because of a number of factors. So I was wondering, and I fast forward until now, until last year, if it was possible to shrink the concept of the smart city and make it portable. So, you know, my dream was to have the Iron Man suitcase that explodes and basically do a number of things in an automated fashion. I'm not Tony Stark because I'm not rich, but the scope of the project was the need for mobility, because I mean, last year and the year before, offices were closed, so I needed a way to present a concept in which I could present, you know, the various use cases in a portable fashion. So I imagined, you know, this kind of suitcase where everything is battery powered, and I could attach, you know, microcontrollers and sensor and whatever, in order to stimulate a number of messages coming from the field and reaching the cloud. Once in the cloud, all this stream of messaging would be analyzed by some components, let's say. So there were two factors: the generation of events in the physical world, the coverage of the stream analysis area, because I mean, according to all the big analysts, the stream analysis area is doubling year over year. Now it's double digit in terms of money spent on the project, on a project. So it's not only, you know, data lake or big data, what it was, or, you know, any kind of modern and classical analytics architecture, but it was all about the fast data. So I receive a number of streams from basically the world, and I need a comfortable way to analyze those streams and eventually, you know, give also some feedback to the field. And that's the innovation that I put into the suitcase. The Proxima city, so the Lego city that you saw before, was one way. So the streams of data coming from this physical city shrink down were reaching, you know, the cloud stuff, and then after the analysis were just, you know, stocked into some kind of big repository. Now, last year we found a way to have a message back to the field, so to the suitcase, in order to, for instance, have a specified use case about the application and enforcement of COVID-related procedure. Consider, and this was the very first use case, consider all the sanitizers in a floor, or consider all the sensors that are connected to a particular door, or consider all the paths that you have to follow within a closed environment in order to enforce the security protocol. You could accrue, you could get some data from the field, analyze those data in order to send an alarm when the security protocol was not operational or was simply broken. There was enough people not respecting the security protocol. So basically, why a Suitcase and why a Raspberry Pi? Because I needed to do demos also in a bar, open air, because there was no office to work with. I needed to cover the stream analytics area, the stream analysis. Fast data is very, very, very important, not only in the industry, but also in the open source. If you pick a project like Apache Flink, it's all about it. I mean, it's all about the analysis of the stream. And of course, giving credibility by generating events from the physical world, not just running a script from remote, but adjusting the sensor and the microcontrollers behavior depending on the environment I was working with. And this was the main scope of the project. So what was the outcome? This is the Mark I. So this is the very first Suitcase that I produced. You can see some components here. Of course, you can see the Raspberry Pi in an aluminum enclosure, no moving parts. You can't have moving parts while having, a suitcase to carry around. Of course, a very large and generous battery pack, and some microcontrollers. I switched to the M5 stack for a number of reasons that I'll describe. And then I started also to experiment with some e-ink products like, the e-paper stuff. There are a number of components that are available on the market. There are pros and cons using M5 stack versus Arduino. Both are Arduino mode, so you can program in C and C++, let's say C with some C++ extensions. But there are some plus from the M5 stack, which are these Q-lidded boxes that I fall in love with, because they have a battery, so they have certain autonomy. They have USB-C plug, which I don't know if it's really an advantage, because USB-C it's a mess as standard. But anyway, you have a battery, a display. You have to be extremely careful in programming the display because it's got a frame buffer. So if you continue to ride on the same line, everything will be overwritten. And then, of course, other than the field components, the battery and the M5 stack, I will have a router, which most of the time works in 3.5G mode due to the scarce coverage in this area. But nevertheless, it's quite functional and working for the scope that we thought about it. Then it was fine for a while. Then, as any other old programmer, I needed to change setup, and I made the Mark II stuff. So more or less with the same components, but I added, of course, the Raspberry Pi display. Why? Because there was a requirement from a customer that needed to see the response time of all the chain from the edge to the cloud and back in terms of milliseconds or in terms of seconds. So the customer wanted to see, the user perception, because it was not really an Internet of Things. It was an Internet of humans, of people. So basically, I needed to add, this kind of screen here, and you can see also the reflection of my smartphone taking the picture. And recently, well, I think it was 10 days ago, I'm in love with miniaturization. So once we realize something, our pulse is to shrink it. I want that to be smaller. And I realized that most of the time when I was presenting this project to universities and research centers, I needed to extract the router and put it on an optimal position or directly attach it to a local Ethernet connection in order to offload, the data, the mobile data, or just because there was no signal in that area. So with this idea in mind, I realized something very, very small, which is susceptible to be, modified, because there is a very big gap here. And I know that I could put in some other sensor and microcontrollers. There's another Arduino, there's an e-ink tablet, and there are, the usual 3 or more. There is a space for a 4th, maybe a 5th microcontrollers in order to simulate more stuff, basically more behaviors from a machine or a customer point of view. So when designing the model, I really wanted to apply this kind of pattern here. So I wanted to generate events from the physical world, in the physical world, send it to the cloud in order to process the event, doing some analysis, but also augment the data. What does it mean, augment the data? Make the data, let's say, larger and richer, an enrichment. For instance, when a message is coming from the field, and given a specified key, I could do some lookups from data stores, or I could do some REST calls in the cloud in order to enrich the data and make it something really valuable for those who needs to analyze this kind of flow, this kind of stream. And when the occasion can be presented, return the result of this kind of data augmentation directly to the suitcase. So basically, it's a closed, let's say, a closed loop architecture in which I will, push some buttons in the suitcase, or not in this case, not today, but maybe attach some sensor and let the data flow, let the stream flow to the cloud, and let the data and stream analytics do their job. What are the components? First and foremost, the Raspberry Pi. I used, as a matter of fact, 2 varieties. This could work also with the Raspberry Pi 3, as a matter of fact. Raspberry Pi 4 gig or 8 gig, depending on the configuration. Anyway, when the suitcase hype will be finished, or if the setup changes, I will reuse the Raspberry Pi as a developer workstation, because we found a way also to deploy a containerized application on a local Kubernetes, and the same container will run on some ARM instances on the OCI cloud. That's very interesting. I think I've written something on Medium about it. So the Raspberry Pi is the core in communicating, gathering messages and communicating with the cloud and receiving the message back. And then, the cute little boxes, the M5 Core and Core 2. The picture here is a Core 2 because it's touch screen. Don't expect the quality of a touch screen like iPhone and Android on these cute little boxes. I mean, it's not the same thing. But as a matter of fact, the Core has got buttons, and we will see that in a moment. The Core 2 has got a very beefy battery, but I found, but this is a personal problem that I have with touch screens, because I'm old I'm vintage. The multi-touch doesn't work as really advertised. But anyway, I use both. For the lazy programmers, MicroPython is available, so you can program in Scratch if you really want. But most of the time, the entire components are programmed in C, C++, so the old-fashioned way. And the display is a nice touch, is a nice addition, because you can see physically, the user perception point of view, not only in terms of milliseconds that have passed since, the origin of the stream, but also has got some visual that can warn you. So, for instance, for a customer, we transformed these cute little boxes, to the M5 and the M-Core2, in a control unit and a cockpit unit of a tractor, in order to get telemetry information and send to the cockpit some warnings or some other messages about this heavy machinery moving through a crop. Then you will need, of course, a bunch of sensor actuators if you really want to perform something in the physical environment. I did it last year when I tried to switch on a red semaphore. When there are too many people inside a room, or too many people that passes through a corridor in a closed environment, you could have a breach of the security or the safety protocol that is deriving from the COVID-19 rules. So we just, closed the door and switched on a big red semaphore. You cannot access this room any longer. And then, of course, the connectivity, which actually has been really an hassle, in my opinion, because I bought a 4G SIM in order to do most of the stuff. And most of the stuff is working on a 3G connection. But since, we don't transport heavy data, most of the information that are accrued and sent are really small in size. It's all right. The battery lasts, a long time, at least 9-10 hours. So, a working day will be perfectly fine to provide this kind of connectivity towards the cloud. So 4 main components: Raspberry Pi, M5 Core or Core 2, sensor actuators, if you want to make it happen, something real in the physical world, and the connectivity side. About the software, what we used the Arduino IDE, or other means. You could use also Visual Studio Code. To do that, I get acquainted with the Arduino IDE, which is open source, is free, is fine, but from the performance point of view, it kind of sucks. But it's quite straightforward. You plug, this M5 stack component via USB-C, and you're done. You just flash the microcontroller and you're ready to go. And of course, as I said before, the battery, the buttons or the touch screen, and the display play a very important part, because you can see visually what is happening. And then, of course, the Raspberry Pi, you will need Mosquito, of course, the MQTT broker. Why did I choose Mosquito and the MQTT broker? Because it's easy. Most of the time, this project has been adopted by students, by amateurs like me. And MQTT is very easy to operate. Maybe it's not, the maximum of security. You will have possibly to change transport and make it secure in order to do something in production with this stuff. But for this, the scope of the Suitcase and the scope of teaching students and having, university professor that helps you to divulgation of this kind of pattern, It would be fine, more than fine. So I will use Mosquito as a MQTT broker and the Node-RED, because there is a little logic between Node-RED, but there is some logic in order to do some measurement, for instance, of the round trip time between the Suitcase and the edge component. What are the components in the cloud? Of course, some compute. You will see that you need the Mosquito counterpart, because we have two Mosquito, one on the Suitcase and the other one on the cloud, on the compute instance. Why? Because we use MQTT bridging in order to pass the messages back and forth. And then there is a small message router written in Python in order to, using the PAHO, P-A-H-O library, in order to get the message from Mosquito. So basically subscribe to a specified topic and routing this message through the OCI streaming, which is a Kafka compatible streaming architecture. And we need the streaming architecture. Why? Because we need high availability, basically, on the cloud side. And then there's another component which is called stream analytics, which is available from the OCI marketplace. It's a technology that can work on cloud, on-prem, on whatever, given a number of processors, of course. And we'll describe that very generally. And then the OCI functions. The serverless architecture are nice. There are some caveats, but I think there are more advantages than disadvantages in having the ASAP approach. ASAP is not as soon as possible, but as serverless as possible. Because you don't have, I mean, it's programmer's nirvana. You don't have to take care about anything. It runs without Kubernetes. It's cloud native, can scale to millions of messages per time unit. So it's fine to use that. And that's the complete architecture of the Suitcase from one side and the cloud from the other side. So I will have a sensor or a microcontroller sending a message to Raspberry Pi, which is connected by a 4G router to the MQTT counterpart. The MQTT counterpart will publish this message to the subscriber, and this small router made in Python will extract the messages from the, basically it's a subscriber, so it will get the message and send the message to OCI streaming. The OCI streaming will point to stream analytics, which will in turn stop the message, memorize the message into some sort of very big bucket, which can have the form of a DB, the Oracle Autonomous DB, or can have the form of whatever you want. But you see the red arrow, so the return path. If something happens, or if I decided that the message will get back to the field, I will use an OCI function to get the message directly on the MQTT broker, which in turn will send the message to the local MQTT broker, which in turn will send the message to the microcontrollers or the sensor. So this is that sort of 101 architecture, which needs several components, but from the portability point of view, all of this will fit a specified Suitcase with the Raspberry Pi and the battery power, so the power bank and all the M5 stack components. So about stream analytics, stream analysis pipelines, this is a very nice product which is based on a lot of open source here. So Coherence, Coherence is open source now. Ignite, Kafka, Hadoop, and Spark, and then there is a tiny layer with which you can develop graphically your own analysis pipeline. And then there are some source and some target. In this case, the source is the streaming, data streaming that is coming from the edge. The target is a function so that we can go back to the field. And that's the, we will see that. That's the user interface, which can be switched off and the system is continuing to work. So you cannot possibly, publish pipelines all the time. Maybe there are some specified time window in order to do that. And maybe it's a business analyst doing that, because it's very, very, very extremely easy to do. And the Oracle function is a nice piece of platform in order to host small pieces of code. So this is the history of the IT. Basically, we are more or less here nowadays with containers like, and big orchestrators like Kubernetes, and we use that all the time. And then we got, a specified category of platform which is all about serverless, which means the abstraction level is so high that you need just to put a piece of code, deploy this piece of code in the platform, and let the system scale for maybe millions of events or billions of events. All of these artifacts here are cloud native. Cloud native means there are several definitions. In my opinion, the best definition is that when you design a piece of software and you don't know, the number of people that will use the piece of software in a particular moment. So it could be the whole internet. Since it could be the whole internet, you need to take your precautions. You may want to use, orchestrators or, the principle of scalability in terms of vertical scalability in Kubernetes or horizontal scalability in Kubernetes, or just rely on functions when you do have some rich pieces of code, but smaller in size, that can be stateless, of course, and multiplied by a number of instances. And there are, many, there is a lot of documentation about this. One thing that I would like to warn you is that when you see this FN with the fin logo, this is an open source project. It's called the FN project, which we managed, and a colleague of mine has done it more than once, which can be hosted on Raspberry Pi, and basically is the basis for the Oracle functions, so the industrialized version. So this kind of architecture based on serverless can scale from a Raspberry Pi, and it works on ARM, until the mega scalable, infinite architecture that you may find on some cloud native applications that basically serve the internet. And I will jump this, but the functions must be triggered. So must be in some way activated. Usually the function is dormant. So when nobody is accessing the function, the function is in a sort of frozen environment. Then you activate the function by a direct call with the API, or there is an event that triggers the function, and the function gains some heat. Let's say it will be heated and is ready to perform these pieces of code. So there are some mechanisms in order to reserve a certain number of hot function in order to have the necessary response time. And there are some other tricks like using GraalVM and Java. So it's a very performant GraalVM that have very tiny startup times, and the startup times in functions is very, very important. So what are the use cases that we basically we designed? The first one was the healthcare. So the analysis of the stream from field sensor like people passage sensor in a portal, or the sanitizers that can be thrown up, can be messed with, can be tampered with, so that I will send the message to the cloud, and the cloud will realize that there is something wrong. So it will take appropriate actions. Then there's the automotive stuff. It was very funny to do that because it's not the classical automotive, on-highway automotive. It was the off-highway automotive. So basically heavy machinery moving through a crop. And with this architecture, we could simulate and intake some telemetry data in order to send the message to the cloud, have the analysis done, and report the result of the analysis onto the cockpit of the tractor of the heavy machinery. And there is the contextual marketing stuff. So the streaming coming from mobile apps and ATMs will produce what in the industry is called next best action or next best offering. So basically the bank or the credit institute or the gas station will send you something because they want to, of course, sell you something. And then the suitcase will act as both the user, so the Internet of People, and the machines, so the Internet of Things. It's a mixture of the two. And in order to see what it's all about, this is today's setup. I just extracted, the sensors, the microcontrollers, and the Raspberry Pi from the suitcase so that we can have clarity of action. And this is the publisher. So you see, we need button to do that. So basically, this will simulate some events coming from the field, like a user entering in near a geofence, a user entering in a geofence, and a user putting the cart onto an ATM or a gas station or whatever. This is a monitor, just prints out, for the sake of clarity, the JSON message that is generated. And this is the subscriber. In the banking example, it would be an ATM. So I insert the card and there would be, in a classical fashion, okay, you are a gold user. Would you like to have another credit card or, lower interest rates or your loans or whatever? And then this is the billboard, so I can take care. I can trace all the messages back and forth. And this is finally the Pi, which unites the field contained to the suitcase and the cloud. You can see in the upper left corner, this is an angle of the. It didn't fit into the picture. An angle of the router that I'm currently using in order to not only stream this webcast, but also to transport the messages in order to go to the cloud and receive response. So to do that, I'm trying to see if this is the live picture of it. This is my disembodied hand, so it's live. And of course, this is the publisher, this is the monitor, and this is the subscriber. You can see here as a glance of the router. And this is the billboard. I like to have a very large billboard in order to project what is actually going on, but it wasn't possible. So I need to use this little cute tablet with e-ink in order to write something whenever it occurs. And this is the Raspberry Pi. I've received in the Slack channel a question about, the heating, because all these components are basically in foam. And I've seen that the difference between, the aluminum cover, the aluminum case, and, quite a small fan, trying to cool down the Raspberry Pi is quite the same. It would never reach critical temperature unless you want to demonstrate this on the beach. There is another use case, let's say, but in normal condition, talking within a bar or in an open place, there should be no problem about it. And of course, there is the stream analysis, which is the core. To do that, we developed a number of pipelines in order to get the message, for instance. And the use case here is the bank. So you will see how it works. These are all the streaming events that are received from Suitcase. So if I press a determining button, you will see here that this is beginning to be populated in terms of device ID, which is the user number, for instance, the sensor, the status, the longitude, the latitude, the longitude, and some other additional stuff. And you basically have two branches: events that are rising from the user, which will correspond to something that happens in a geofence. And I've chosen a geofence by designing it manually, which is not too far from here. It's actually something like 500 meters, in order to represent something that is happening in the analysis pipeline. For instance, I will press a button of a user near the pipeline, and you will see that I have a way to mark the user as near, and of course the near let's say state is detected by the distance buffer. So for me, for my use case, whenever a user or recognized user is within 300 meters from the geofence, it can be considered as near. Then, of course, another very important event is when the user enters the geofence in order to prepare all the backend systems in order to do something. And you can see the user is quite near, and you will see that this user is near a sensor which is a detection point. It has a user number, and of course the user didn't do anything right now, so it's just near the geofence, and you can see the status here, or enter the geofence. Then something magical happens, so the user puts let's say a credit card or a debit card into the ATM, and that is intersected by another piece of the pipeline. For instance, and this is more articulated, there are a limited number of information that are present on the credit card. So it means that in order to vehiculate the marketing message via the ATM to a particular user, I have to enrich the profile. And of course, as always happens, the profile of the customer is distributed in different departments. So there will be the IT, which holds the user profile. So for instance, how much money do I have in my bank account? And then there is another branch of the business, which is the marketing, that wants to send a particular message to that user in order to promote new products and services. So basically, these are two data sources external to the pipeline that I have to reach in some way via REST APIs. And the number of systems that you can reach is quite large. So REST calls, DB calls, MySQL calls, MongoDB calls. The possibilities are endless, but you need something, very prompt in doing that, because this is not a business process management. This is a near real-time analysis of events. So in order to enrich the message, what I will do is to hit this different data source. And by doing that, I will enrich the profile in order to get a specified message to be sent to the user. In this case, I will press the gold promotion because I'm a gold user. And you can see that the system is quite prompt. It's quite fast. We are talking about events. We are talking about streaming. We cannot sit and think about the things to do. Everything must be done quickly. So what I will do now is to do the same thing with this camera here in order to let you see the what's really happening. So let's try to reset the pipeline by positioning my mouse at the beginning of the pipeline, and we will put in foreground this camera. So this is the publisher. So basically, it's the user. There are 3 buttons here. I'm using the national flag. So the green button is near. The white button is enter. So near a specified geofence and entering a specified geofence. And the red one is the card. So the user puts a card into the ATM. So let's see about the visual response time. I press the near button, and you will see that the message has been received here in the pipeline, but you will see that the ATM or another machine which is on the field has already received the user near geofence. You see, it's quite prompt in terms of response time. And the other button will be entering the geofence. And the user within geofence. So you see near and entering the geofence. And you will see that we basically have respected one of the requirements. We have fulfilled one of the requirements from one of the customers saying, these things, whatever it is, must be fast and must process events in the fastest way possible. Considering that I'm reaching, the cloud with a 3.5G connection with just 1 bar, and considering that I'm using, toys to demonstrate this concept, the latency is fine. It's quite fine for the demonstration of what's happening in near real time. And you can see also that every message is let's say, written onto this log here, to this journal, in order to giving evidence of what has been done. And the third button, of course, will be the card. The card takes a little bit longer because, there are some necessary wait time, because I'm interrogating and doing lookups to 2 different data sets. One that holds the user profile, the other one that is holding the marketing information that I want to deliver to the user. So, but as you can see, it's quite prompt too. If I do it again, of course, you can see that the response time is quite acceptable for this kind of components used for this architecture. So basically, as you saw before, all of these components are contained into a suitcase, one large, which I called Spectre, like the Spectre the James Bond stuff, because I mean this was the code name which was named by a customer. And you can see that if I reset the the microcontroller, it will have the Spectre logo because it's a specified version. I'm hoping that I don't breach any kind of copyright, otherwise I will be in trouble. The boot time is quite fast. The heating about the microcontroller is near zero. These microcontrollers are based on ESP32 SOC. So it will drive, the storage, if any, the buttons or the touch, the displays, and of course, I mean the battery. These are the advantages. The disadvantages is that you just have the API. Let's say there is no very detailed information about how to use them. So you will have to do some discovery. I did it on different platforms and different kind of components, and I've reached, let's say, quite a satisfactory result. And of course, I mean, this consumes so little power. The Raspberry Pi with a 10,000 milliampere per hour battery pack could be on for something between 5 and 9 hours. The Core 2 can last something like 2 hours. The Core 1, so the basic, the one that's got the button, they last less, maybe half an hour, 3/4 of an hour, 45 minutes or something like that. But I really needed to have buttons because I like buttons. I'm old, I'm vintage. And when you are presenting something or doing a demo in front of the customer, you can't rely on your eyesight in order to touch the right button. And also the touch kind of sucks in terms of response. It's a multi-touch, but don't expect, as I said before, the multi-touch of an iPhone or an Android. And basically, this is it. Let's do the recap, what we have seen today. We have seen a portable architecture, which is made of M5 stack components in Arduino mode, in Arduino compatibility mode. You can program them if you want also in MicroPython, and you will have better graphical results. You see, this is the, let's switch on the live one. This is the matrix style, because I'm old. That basically is a monitor of the message that is being sent to the cloud. So the user interface, I mean, in this case, sucks because I did it. So I used basically almost no user interface, just characters. But you can design very clever stuff if you are a front-end person. And if you are a front-end person, you are lucky because, I mean, mostly of the front-end developers are paid a lot more than the back-end developers. Anyway, we presented also, these kind of things here. As you can see, there are some very basic mechanisms in order to clear the screen. So I'm generating a number of events here, and you will see that in a while, the limit is reached. So the screen will be cleared, and there will be other stuff which can be preserved on the storage card. Every one of them has a storage card in order to deposit events or log or whatever, if it's necessary. There are some few minutes left. If there are some Q&A, please use the Q&A channel. I will be more than happy to respond. Otherwise, you will find myself, unfortunately, on social media like LinkedIn and Twitter. I don't use much social media, but I think there are many ways to get my mail. and usually I respond. But if you want to connect on LinkedIn and discuss about this stuff and maybe make it something that potentially can be, exposed to all over the world, I will be more than happy to do that. So I'm in the finish line. I will remind you, and I'm switching back to the presentation, that there will be some PI quiz to be responded if you want to, get some other stuff. The recording of this presentation will be available after short. There is an article which is made on the Oracle developers blog, which I'll show you. If you go to developers.oracle.com and community, well, it's no longer on developer.oracle.com, it's on build. Devo build. If you search Devo build, cool Devo build. Let's consider, it should be here if you search for Proxima Safe. There is an entire article divided in 3 sub-articles in which there is written everything that I described here, and there are some pieces of code, and there are the instructions on how to set up such an architecture on OCI, and yada, yada, yada. So basically, what we reported here is the first use case, which was the enforcement of COVID-19 protocol in a closed environment. So this is it. I hope that you enjoy the session. Please do the quiz because it's fun. I mean, it's something that everybody can do that. And I hope to see you in the next future. Please get in contact. You will find all the manners to get in contact with me. And I thank you once again for participating to this flamboyant Pi Day 2022. And this was the Suitcase, so the battery powered Suitcase and the Stream Analytics in a box. Thank you once again.